What's up, geeks, and welcome to the channel. Since Java 5, annotations have shaped the way we design our applications. And simply put, an annotation is a Java type preceded by the @ symbol. Basically, it assigns extra metadata to the source code it is bound to. By adding an annotation to a method, interface, class, or field, we can inform the compiler about warnings and errors, manipulate source code at compilation time, or modify a certain behavior at runtime. In today's video, we're going to create our own custom annotations and then try to make use of them with the help of Java's Reflection API. So the goal here is to create two custom annotations that will help us serialize an object into an XML string. What you see is the end result we are trying to achieve. So, given a certain class annotated with our custom annotations, when an instance of this class is created, we will have the ability to represent it in XML. The first annotation will be used on the class level to indicate to the compiler that our object can be serialized. Then we'll apply the second one to the fields that we want to include in the XML string. Okay, the first step toward creating the class level annotation is to declare it using the @interface keyword, as you can see. This tells the Java compiler that this is a Java annotation definition. Next is to define the attributes, or what we call elements of an annotation. Notice how each element is written similarly to a method definition in an interface. It has a data type and a name. In our case, we will have a single element, tag. This element will allow us to replace the name of the attribute of the annotated class with something else, as you can see in the example. You can use all primitive types as element data types, and you can use arrays as well. But you cannot use complex objects as data types. If you specify default values for an element, that element becomes optional and can be left out, just like a couple attributes of the bank account example we gave at the beginning. Okay, the next step is to add meta annotations to specify the scope and the target of our custom annotation. This is done by using the @retention and @target annotations. Here we will have runtime visibility. That's what signals to the Java compiler and JVM that the annotation should be available via reflection at runtime. The retention policy class contains two more values you can use, class and source. Retention policy.class means that the annotation is stored in the .class file, but it is not available at runtime. This is the default retention policy if you do not specify any retention policy at all. And the retention policy.source means that the annotation is only available in the source code and not in the .class files nor at runtime. This one is useful to avoid polluting class files if the annotations you're creating are used with build tools that scan the code. Concerning the @target annotation, here it was set to type, meaning this annotation can be used on classes, interfaces, enums, or other annotations. What you see now are the possible targets contained in the element type class we just used. They help you specify which Java elements your custom annotation can be used on. Almost all of them are self-explanatory. The most confusing one is the annotation type target, and it means that the annotation you're creating can only be used to annotate other annotations, just like the @target and @retention annotations we just made use of. Okay, the second annotation needed to complete our bank account example will be the @XML element annotation. This one is pretty similar to the one we just created, but the only difference is that its target level will be the fields or attributes of our annotated class and not the class itself. Okay, before proceeding, pay close attention that here we created annotations that go on classes or fields, but be aware that when using the element type reserved for methods, these methods must have no parameters and cannot throw an exception. Also, their return types are restricted to primitives, strings, enums, annotations, and arrays of these types, and the default value cannot be null. Now, let's see how we can make use of these custom annotations, and let's imagine that we have an object of type bank account and its class is decorated with the annotations we just created. One way to take advantage of these annotations is through Java's Reflection API. So, after retrieving the class corresponding to our given object, what we need to do is loop over the fields of this class, Then make sure that each field is indeed accessible in case its visibility was set to private. And now that we can access it, we check if the XML element annotation is present, and if that's the case, we retrieve the field's value and append it to the string builder we created in an XML-like format. To make use of the tag elements we added to our annotations, we created these helper methods that retrieve the corresponding tag value, if not empty, and use it instead of using the actual field or class name. Finally, we append at the beginning and at the end of the result the class tags and return with the string containing the XML representation of the annotated class. Okay, you could go ahead and add additional checks at the beginning, like making sure that the class itself indeed contains the XML serializable annotation, or perfect the output at the end. But we leave it at this, as my goal is to focus on creating the annotations themselves while keeping the usage example as simple as possible. Now, for the second part of this video, I will tackle a couple annotations that can also be used while creating your own custom annotation. First, the @inherited annotation signals that a custom Java annotation used in a class will be inherited by subclasses inheriting from that class. What you see is an @inherited Java annotation example. The class subclass inherits the annotation @myAnnotation because it extends superclass, and superclass has the @myAnnotation annotation, which itself is annotated with @inherited. Note that by default, annotations are not inherited by child classes. Next is the @documented annotation. You will not be using this one often, but you should know it exists. It is used to signal to the Java doc tool that your custom annotation should be visible in the generated Java doc of the classes using that annotation. What you see is an example of the generated Java doc in IntelliJ when we apply the @documented annotation on a certain annotation versus when we don't. Okay, other than that, what Java offers are the simple annotations we are used to, like @override, @deprecated, or @suppress warnings. With these, we can annotate only our code. We can't use those uncreated custom annotations. Finally, I've already mentioned it, but the annotations we're discussing, @target, @retention, @inherited, or @documented, are meta annotations, and they're designed to annotate other annotations. So, that's it for this video. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.